I'm Darren Meyer, the lead solution architect for Endor Labs. Let's talk about software dependencies and their impact on security. There are basically two categories of security considerations when you're importing an external library, especially an open source library. There are mistakes, things that happen by accident that lead to some kind of a vulnerability, and there are deliberate actions where a malicious actor wants to introduce a security risk to some target, which may or may not be you, but will impact you directly. Developers that work on the libraries and apps that you depend on can just make mistakes that lead to vulnerabilities that impact you. You need to be able to find them and reliably patch them. And where you cannot patch them, you need to be able to reliably mitigate them because their risks that they've introduced affect you now that they're part of your software. On the other hand, malicious actors can take deliberate actions to introduce security risk. They do this by a handful of ways. The most common are unauthorized modification of a legitimate dependency, something I like to call subversion. This is where somebody takes a dependency that you are going to rely on, and they somehow get access to its source code, either through social engineering or recovering some kind of credentials, and they add illegitimate code, malicious code, to that legitimate dependency. The next time you download that dependency, you inherit the security risk that they've introduced, possibly a backdoor, possibly some kind of data harvester, possibly some kind of coin miner, something along those lines. Or they could trick you into using a malicious package that's similar to a legitimate dependency. That's something we call dependency confusion. So this relies on things like application developers making a typographical error, right? If they use a slightly wrong spelling of something, someone might register that wrong spelling and put a malicious package there that does all the right things, but also contains malicious software. They can also do things that are designed to show up in searches. So when a developer is going, I remember there's a dependency named X, and they go and search for X, maybe they'll see something they think is right on the list, and it's actually the wrong thing, and it's actually a malicious thing. This happens a lot because several names for dependencies have deliberate misspellings for kind of brandy reasons or for memorability or in-jokes or whatever the case may be. And sometimes a malicious actor will just put the real spelling and trick people into downloading this thing. And the last general strategy is to produce a legitimate seeming package that has malicious side effects. This is called infiltration. So this is where an actor creates a useful package, and from day one, their intention is to add malicious code and malicious capabilities to it. This often happens with things like Chrome extensions in the application world, but also happens with software libraries, where I create a package that has some utility to you as an organization. You download it, you use it, it's fine, and then I later add a Bitcoin miner, or I add a data exfiltration, or I add a keystroke logger, or whatever the case may be, to that originally legitimate package, right? These are all things of malice aforethought that are after you and your organization, but they may not be targeting you specifically. They may be general broad nets to target you. They may be targeting someone that's very similar to you and you get caught. These two things are different enough that they suggest different courses of action, right? When you have mistakes, what you need to be able to do is understand the impact of the mistake, catch them relatively quickly when they happen, and be able to decide on how bad is this for me really, what is the real risks that I have, prioritize my response. And probably you're not going to be able to fix every issue, every risk that comes into your environment that's the result of a mistake, but you can fix a lot of them. And you can certainly use tools and processes to be able to identify the ones that are most critical to your organization, the ones that have the biggest impact, the ones that are in use in key production systems, for example, and come up with a regular patching and repair process that you can follow so your developers know exactly how to respond when you uncover these things. Malice is a little bit different. At its core, being able to respond to malice, you still need those capabilities from responding to mistakes. You also need to be able to look at a kind of a broader lens of things, because a malicious person is going to attempt to hide things from you. So you can't necessarily rely on there being a disclosure like a CVE in order to identify that there is a malicious piece of software. So you need to have things like threat intelligence feeds, and you also need to look at various behaviors. So you need tools, for example, that can look and say, here's a known legitimate package. Here's one that's been added to your environment that's very close in name, but is far less popular, far less used, and can flag that for a human being to go investigate and say, hey, is this potentially a malicious item? You have to look for things like runtime analysis so that you can look at, hey, where is this reaching out to on the network? If I'm expecting this to reach out to Google services and suddenly it's reaching out to an unnamed server in China, right? That's unexpected behavior. I want to know about that. I might need runtime egress controls. I might need to look for behaviors that I don't particularly expect or want. At the end of the day, though, all of this has to come down to malice is always critical, but anything that's a mistake, there's a lot of them, and you have to be able to prioritize and respond on some value of what is the real risk to my organization.